Hundreds of thousands. That's a pretty staggering number, right? Well, what if I told you that's the estimated number of chemical substances sitting right there in a typical Western diet? Yeah, literally hundreds of thousands. So if you've ever caught yourself thinking that a natural meal is somehow completely chemical-free, prepare to have that myth totally shattered. Every single bite you take is this absolute masterpiece of complex chemistry, and the wild part is, most of it is completely natural.
So welcome to this explainer. I am super thrilled to have you here with us today because we're embarking on a genuinely fascinating journey into the reality of food safety and toxicology. If you're the kind of person who loves figuring out how the world actually works, you are in the perfect place. We're going to cut through the noise, drop the marketing buzzwords, and decode the real science behind what's actually safe to eat.
Here's our roadmap for today. We're looking at 1. The chemical soup we eat, 2. The dose makes the poison, 3. Your built-in gatekeeper, 4. Defining safety and law, and finally, 5. The 2 bars of safety.
All right, let's jump right into Section 1, the chemical soup we eat.
Okay, so the biggest paradigm shift we need to make right out of the gate is realizing that food is, arguably, the most chemically complex thing we will ever put into our bodies. I mean, we usually just think about our food in terms of those basic, life-sustaining nutrients, right? Carbohydrates making up about 47% of our calories, fats at around 37%, and proteins at 16%. Throw in some essential vitamins and minerals, and we kind of assume that's the whole picture. But honestly, that is just one side of the coin.
See, scientists actually split food into 2 separate buckets. We just talked about the nutrients. Now we need to talk about the much, much larger everything else bucket. These non-nutrients are what give your food its gorgeous color, its mouth-watering flavor, its aroma. This massive bucket includes naturally occurring plant and animal substances, intentional additives like preservatives, tiny trace amounts of contaminants like metals, and even chemical byproducts that are created just by the simple act of cooking. So yeah, an unprocessed meal is anything but simple.
And here is the real kicker. Nature is, without a doubt, the most prolific chemist out there. Get this. Plants naturally produce around 10,000 distinct pesticides just to defend themselves in the wild. 10,000. Meanwhile, human beings intentionally add only about 3,000 substances during factory processing. A completely natural organic banana or even just a standard cup of black coffee contains hundreds of distinct chemical compounds. It just goes to show that natural and chemical-free are absolutely not the same thing.
Moving right along to Section 2, the dose makes the poison.
So, you're probably wondering, if our food is packed with tens of thousands of chemicals, how are we not getting sick? Well, it all comes down to the absolute golden rule of toxicology. Literally nothing is inherently just safe or toxic. It is 100% about the amount. Think about water for a second. It's the most ordinary, life-giving substance on the planet. But if you drink way too much of it in a really short window of time, it can fatally dilute your body's salts. At an extreme dose, even water is incredibly dangerous.
And this rule applies to our essential nutrients too. You literally need vitamin A to stay alive and, to see. But it actually becomes toxic at merely 10 times the amount required to prevent a deficiency. Think about that. That is an incredibly narrow safety window. A substance that we desperately need to survive actually becomes actively harmful just by tweaking that dose slightly upward.
Now, let's flip that entirely. Picture a flask of strong acid in a chemistry lab. Highly corrosive, right? Incredibly dangerous. But if we use those exact same strong acids safely at microscopic levels, they're exactly what we rely on to control acidity and stop dangerous bacteria in delicious, everyday foods like cheese and cured meats. High doses of safe things can be deadly, and low doses of harsh things can be incredibly protective. It's all about the dose.
Which brings us to Section 3, your built-in gatekeeper. We've been talking a lot about this complex chemical soup on our plates. But how does our biology actually process all of this without us even realizing it? Well, think about a lab pill. It's manufactured in a highly controlled factory to extremely precise specifications. Every pill is uniform. But raw food? You can't just manufacture a tomato. It grows in the dirt. It's subject to the weather, geography, and basically pure chance. Raw food varies wildly from batch to batch, and it's never going to meet the uniform purity standards of a factory-made pill. Because our food is so wildly unpredictable, our bodies had to evolve a genuinely phenomenal defense system. It's basically a 3-step process. Step 1, a massive surface area filter. Your digestive tract isn't just a tube, it's this huge, highly active organ, completely folded and frilled to create a surface area roughly the size of a studio apartment. Step 2,
A neutralizing chemistry lab. The cells lining your gut neutralize foreign chemicals almost as powerfully as your liver does. Often, a potentially toxic natural compound is completely broken down before it even hits your bloodstream. And step 3, trillions of bacterial helpers. Your gut bacteria perform incredibly complex chemistry that human cells literally cannot do, breaking down this wild chemical soup into perfectly manageable pieces.
Next up, Section 4, Defining Safety in Law.
Okay, so we've seen the biology side of things, but how on earth do government regulators actually manage all this? The people who drafted the U.S. Food, Drug, and Cosmetic Act had to swallow a pretty hard, pragmatic truth. You can never, absolutely never, prove that something is 100% safe. Since practically every food naturally contains something toxic at some minuscule microscopic dose, a zero-risk rule would literally outlaw ordinary food. We'd have massive food shortages. So they went with a standard that actually works in the real world, a reasonable certainty of no harm.
And they back that standard up with this really brilliant legal concept called de minimis. Essentially, it means that if a risk is so small that it's completely meaningless, it just doesn't need to be regulated. It's a built-in sense of proportion. It's specifically designed to keep us fed and safe without causing mass panic every time a super-sensitive lab test finds a trillionth of a gram of a scary-sounding chemical in a perfectly normal apple.
And that leads us to our final section, Section 5, the 2 bars of safety.
Because nature is just so unpredictable, regulators don't judge everything on our plate by the same standard. Traditional foods, think of a standard potato or a steak, are presumed safe. Why? Because they're time-tested by humanity. To ban a traditional food, regulators would need undeniable, clear evidence that it is ordinarily harmful. Just finding a natural toxin at low levels isn't enough. But added or contaminating substances face a much stricter bar. A brand new synthetic additive can be ruled adulterated if it merely may be harmful. They don't even need proof of actual injury to pull it from the shelves. Regulators basically trust time-tested nature, but they demand rigorous, hard proof for new factory additions.
But what about all the ordinary stuff we add to our food every single day, like salt, or vinegar, or spices? Well, that brings us to GRAS, which stands for Generally Recognized as Safe. Certain ingredients get a pass. They don't require brand new, multi-million-dollar lab studies. And the reason is that qualified experts already agree they have a super long, incredibly safe track record of common use, usually dating back way before 1958. We rely on history and expert consensus here, so we aren't forced to reinvent the wheel every single time we put a dash of black pepper on our eggs. So I want to leave you with this final, really provocative question to chew on. If every single natural bite of food you take is a massive chemical puzzle that your biology is already perfectly built to solve, should we really be fearing our food, or should we just be respecting the dose? Once you wrap your head around the fact that natural absolutely doesn't mean simple, and that your own gut is this master chemistry lab, I think the fear really starts to fade. And it gets replaced by a profound respect for both your amazing biology and the dinner sitting right there on your plate. Keep asking questions, keep looking at the data, and I'll catch you in the next explainer.